Okay, a brief history of Node.js. This is the guy who created it, Ryan Dahl. It's not the most flattering picture, but the first version was released in 2009, and was first presented at JSConf in Berlin, and was a smash hit right away, very popular. There's a talk. The talk is online. If you have an hour to kill, you should view it because it's quite interesting. Ryan is a good speaker. And we were chosen as Technology of the Year 2012 by InfoWorld, which is mostly a magazine for managers, but hey, it's something at least. Okay, who uses Node.js? Here are a couple of companies. I presume that you will know most of them. Microsoft is an interesting story. They even sponsored Node.js. More in particular, they sponsored me to port it to the Windows platform, which, if you're interested in, you should come to Dublin on the 18th of October, 18th of this month, because we're going to talk about it on the Node Dublin conference. You're all invited. So, what is Node.js? Is there anyone here who has never heard of Node.js? No one? Okay. Well, then I don't have to go into excruciating detail, but Node.js is server-side JavaScript. It has a very strong focus on non-blocking I/O, which is something you don't see in many other languages and other frameworks. There are a couple of exceptions, of course. There's also a strong focus on keeping the core of Node.js, the Node binary, what you download from Node.js org website, to keep it small, to keep it lean, to not pull everything into the core. And that's something I will get back to later. But we strive for minimalism. Everything that's not strictly necessary should go into third-party modules. There are some who say that, hey, HTTP, we support HTTP natively. That could have been a module. It's true, in hindsight. And maybe someday we will pull out the HTTP module or and put it into NPM, which is the Node Package Manager, which is also something I will get back to later. Some people with a Ruby background told me to say to you that Node.js is like an event machine. Does everyone know event machine? Raise your hand if you've heard of event machine or worked with it. Okay. It's like event machine, only truly everything is asynchronous, and there is zero risk of having some blocking code somewhere deep inside the library. Oh, and here are some statistics, lines of code. So Node.js is built out of several libraries, modules. V8, that's the JavaScript engine that also powers Chromium, Google Chrome. It's by far the largest component in Node.js. It's over 600,000 lines of code. It's truly massive. If you are ever going to try and read the source code of Node.js, don't start with V8 because it's a rabbit hole. If you start, you won't come out for days and days. OpenSSL is the crypto library. It's, well, not very interesting. libuv, however, is interesting, particularly because that is the thing I work on most. And it's something I very much like to talk about, but I won't inflict that on you today. But libuv is a C library, and its goal is to implement asynchronous network I/O and file I/O on all the platforms we support. That's Linux, OS X, Solaris, FreeBSD, NetBSD, OpenBSD, of course Windows. Then we have CRS, that is the well, the network resolver library. If you do a DNS lookup, a name lookup, CRS is what you sometimes but not always will use. This is one of those details you are free to forget. And then Node.js itself. Node is part JavaScript and part C++. And the C++ code is really bindings to, well, V8 and libuv. The C++ component of Node is, well, it's not much more than glue to other libraries. Okay, so I mentioned server-side JavaScript. One language to rule them all. So I speak to a lot of Node.js developers, and what most people enjoy most about Node, it's not the great libraries, it's not the fact that everything is asynchronous. What they enjoy most is that you write your code both on the server and on the client in the same language. You always use JavaScript, you can reuse a lot of code, and there are no context switches from one language to another, so no switch from Ruby to JavaScript and back again, or Java and JavaScript and back again. Presumably, it's a great productivity booster. So server-side JavaScript. It's not comparable with Netscape Server. Has anyone here ever, who has here heard of Netscape Server, has worked with it? It's a really ancient technology by now. No one? Absolutely no one? Am I that old? Okay. JScript, classic ASP, anyone? No one? Oh, 2, 3. Yeah, you're all 3 relatively old people, I think. I'm 30 as well, so don't take it the wrong way. Okay. Non-blocking I/O. This is one of the key features of Node. But first, blocking I/O. Is the code example readable? Yes? No? Maybe? Okay, I see more people nodding yes than no, so I'll assume it's readable. Okay, so this is a blocking example. It's quite simple. We make 100 requests to google.com with the venerable HTTP 0.9 protocol. Well, the example speaks for itself. It's really plain, straightforward code, but it's not fast. You do 100 requests sequentially, so it will take at least 100 times the minimal request time, and in reality, network latencies and servers are quite variable, so it will take a lot longer. Well, there is an alternative approach that is blocking I/O, but you spawn a new process for every connection you make, which is a quite viable model for an application. I mean, it's what Apache, the HTTPD server, has been using for, well, I think over 15 years now. So, it's still pretty straightforward. It's also quite fast. I mean, you make 100 concurrent, simultaneous connections, so that's pretty good. However, spawning a new process for every connection is not cheap, because processes aren't cheap. And if you want, I can go into excruciating detail about that. But the fact is, for example, a 32-bit machine, you'll be lucky if you can spawn, well, let's say 2,000 or 3,000 concurrent processes. So it's a viable model, but as long as you're using operating system, processes, or threads, you can't really scale out. You will be wasting a lot of resources on your machines. And that's okay if you have a simple application, but if you're, well, for example, LinkedIn, that's a nice example. LinkedIn used Ruby. I think they even use Rails for their mobile website until about a year ago. And they had this server park of, I think, 15 or 20 servers. And those servers were being maxed out. So they rewrote it to Node.js, and they were able to reduce their server count to 3 or 4. And it's the same application. It does, as far as I know, exactly the same things, only, well, a bit more efficient. But still, the pre-fork model is, well, it's not without merit. It works quite well, but there are a couple of caveats. Well, now, on to non-blocking I/O. So what happens here? We make 100 connections, but instead of blocking until the connection is complete and until we've written the request and have read the data, what we do, well, for example, net.connect, what that does, it gives you a kind of promise in that it says, hey, I'm going to make the connection, and once I've finished making the connection, or if an error occurred, I will give you a ring back. Same for reading data and same for writing data. Who here has, well, for the people that work with Node, you've obviously worked with the asynchronous model. People that haven't worked with Node, who of you have used anything remotely like this? Quite a lot. Did it take a lot to adjust your mindset to comprehend the model? Because that's something that often turns out to be well, quite an obstacle for people coming from languages that are not so async focused as Node is. You can speak up. No one had any trouble? Okay, excellent. Okay, so what are the benefits? Well, it's fast, obviously. You're being very efficient with your resources. The problem is you have a lot of callbacks and it can make code quite hard to read. And that is an often heard complaint about Node.js, and it's, well, not entirely invalid. However, there is another model that Node also supports, and that's called streams, which is still asynchronous. But what you do, you have a stream which is fairly similar to a Unix pipe. You know how you can pipe the output of one process to another, and that process can do something with the data and write it out, and you can pipe it to yet another process ad infinitum. That's exactly what streams are. So what we do here, we make the initial connection, and once it's done, we say, hey, send this to the process, and whatever comes back, pipe it to the, now in this case, standard output. Well, it's, in my opinion, very readable, not much more complex than the synchronous examples. So there you have it. Okay, the small core and the rich module ecosystem. Okay, so Python has this slogan, batteries included, which means that the standard library is humongous. It contains almost everything you could ever wish for and ever imagine. I mean, well, the standard things like UDP, TCP, SNMP, POP3, IMAP, I can go on, I can go on and on and on. Which is nice for the application programmer, because you get everything out of the box. Well, nearly everything. However, the problem with such a huge core, with such a huge standard library, and I mentioned Python here, but it also applies to Java, for example. The problem is that once something goes into core, it essentially has to be frozen forever. Because people use that core library. If you ever change it, people's code will break. And when people's code break, people complain. And rightfully so, by the way. Kenneth Reed, who is a fairly famous Python developer, said it very well. The core is where modules go to die. Once a module goes into the core, into the standard library, it's frozen. You cannot touch it. So what usually happens, it only receives bug fixes and it gets deprecated and superseded by something newer, hopefully better. Well, that's the story with Python and Java and some other languages. So we aim for minimalism, a small core which keeps us flexible, and also means that I have to maintain less and that I can go home at 4. When I showed this to my colleague, I mean, it's obviously meant as a joke, but he said, hey, that's how it is. So, NPM, the Node Package Manager. Well, everyone's obvious first Node app is, of course, a chat app. And that's what we're going to be writing here. If you want, you can follow along. The code is on GitHub. Can everyone read it? Okay, I've heard that wireless is really bad, so... okay. Oh, wait, we can... Here. If you want, try and connect now if you have a laptop. And we can do some... Anyone here with a laptop that can connect? Please do it for me. I've been slaving all week over this example, you know. Okay, I'll be moving on to the next slide, but if you want the address, just yell and I'll bring it to the front again. Okay, NPM. NPM is the package manager, it's the package manager. In the very distant past, we used to have 2 or 3 package managers in Node, but NPM killed them all. Which makes things really simple and straightforward if you want to develop a module for Node. So, NPM tries to be quite user-friendly. If you want to make a new module, you mkdir a directory and type npm init. It will ask you a couple of questions. Well, it's quite self-explanatory, I think. And npm generates a package.json file for you. Well, not too interesting. npm has commands to edit the package.json file, but it has commands for most things you could ever wish to add to the file, but you can, of course, also edit it by hand because it's just plain JSON. So, let's go over the index.js file, the actual code. Node has a very simple module system. If you compare to, for example, Python, well, trying to import or export things to and from modules in Python, it's complex and there is a lot of margin for error. Node, on the other hand, tries to keep it, well, that stupid simple. So, your module is just a single JavaScript file. You can import more files if you want. You have complete control over what you export through the export statement. In this case, we export two functions, start and broadcast. Is there anything I want to say about this page? No. What we're building here is essentially the most basic chat app you could ever imagine. So, you've written your code, now you want to make it available to the world. That's also that simple. npm publish. The first time you want to publish a module, npm will ask you a couple of questions like who you are, what do you want your username to be. I think you have to also pick a password, but it's been a long, long time since I last had to do that, so I might be mistaken here. Anyway, npm publish, npm uploads it, packages it, does everything, and in a couple of seconds your module is available to the world for all to see. Now, so we've made a module. How can we use it? If you've cloned the repository, there is an example in another branch. Here's the package.json for the example. So this is a very simple file. Actually, I think the only thing you need here is a name, a version, and the dependencies. The one dependency here is obviously the chat example. Okay, here is how we started. Now, this is the part where we presumably have some live interaction, where everyone connects to this address and we have a live chat server, but is it actually working for people? Damn. So much work. Well, no, okay, I wrote it in 20 minutes or so, but still. I skipped a step, sorry. So once you've written your run.js in this example, the code that uses our chat example, you type npm update. npm, by default, installs all your dependencies in a local directory called node.js. It's possible to install things site-wide, so machine-wide, globally. That's what the -g flag does. But installing everything into your local repository has the great advantage that both versioning and distribution of your software becomes really, really simple. This is also one of the things Node does right and Python's package management does not. I cannot really speak for Ruby because I don't know. I think Gem is the Ruby package manager. I've only worked on one Ruby project, a Rails 1 project back in 2007, I think, so honestly I don't know Gem all that well. But I do know Python quite well, and trust me on this, package management in Python is really messed up. Node does it right. And with that, we are purported to have live interaction. So no one can connect? Helaas, helaas. Okay, too bad, too bad. Try it. Yeah, well, we did. Okay, now I intended to have a section here about how the components of Node integrate. with a focus on libuv, because, hey, that's the thing I like to talk about most. However, shame on me, I did not quite manage to finish it. My battery was dead, so hey, what are you going to do? And there was not a wall socket inside, so. However, I will try my best. So, this is how Node used to be. We have the JavaScript library, and there's a lot of C and C++ code. In particular, we used to use libuv and libeio, which are, well, libuv is a C library for doing asynchronous network I/O, or really any kind of file descriptor that you can watch for asynchronous events. However, that's not all file descriptors, and that's where libeio comes in. On Unix, you can watch, for example, sockets and pipes in an event loop. Regular files, however, don't quite work that way. If you put them in an event loop, in a poll set, they will always fire. They will always tell, hey, I'm readable, hey, I'm writable, even if they really aren't. And to work around that, we used libeio, which is essentially a thread pool that we offload file operations to. So if you want to open a file, in Node it's fs.open. But what actually happens is that the C runtime makes requests, puts in the thread pool eventually picks it up, does its thing, opens the file, and passes the file descriptor back to the main thread. In case you're wondering, yes, Node uses threads under the hood, but as a programmer, as an application programmer, you don't notice that. It's not visible. Okay, so that's what libeio does. If this is becoming all too boring, please tell me and I will stop immediately. I mean, even on conferences that revolve around Node core development, this is usually the part where people's eyes start to glaze over. So I won't hold it against you. Okay, libuv, libeio. They both are pretty good libraries. They do one thing and do it well. The problem is that they're really Unix-centric. And that was a problem when we wanted to port Node to Windows, because Windows does indeed support asynchronous I/O. And actually, Windows supports it in some respects a lot better than the Unixes do. That story I told about file I/O not really working in asynchronous fashion, that you need to use a thread pool, well, it works a lot better on Windows. Okay, so libuv and libeio work great in Unixes, they don't work so well on Windows. So what we decided was to, well, not quite remove them, but to build something on top, and that abstracts I/O, be it network I/O or file I/O, in a platform-independent fashion. Well, that library is called libuv, and maybe I should come back to this. That library is called libuv, and it works well. It's also quite popular. Julia, that's the new hip language for numeric computing. Any one of you heard of it? Yeah? Okay, cool. It's a replacement for the R languages, which is also popular in statistics and other branches of mathematics, but it's kind of crafty. Okay, enough about Julia. Rust is a language developed by Mozilla, and it's quite similar to Golang, but it has even a more strong focus on being very low level, it should in theory be possible to write an operating system in Rust while still giving you the expressiveness of a higher level language. The Rust people are doing really innovative stuff. So if you have a chance, you should check it out. But one of the innovative things they do is that they use libuv under the hood. There are also, I think, about 10 different language bindings now. There are bindings for Ruby, if you care for that, for Python. I think someone did bindings for Perl. There are still people who use Perl, and now they can use libuv. Okay, now we come to the part where I was going to explain why libuv and Node until recently did not work well on Windows. And this is the part where people's eye really start to glaze over. So, on Windows, I should mention that libuv does work on Windows. However, it uses Unix APIs. Windows has limited support for POSIX, for Unix APIs. But the problem is that the subset they implement is the really slow and inefficient part. In particular, the select system call. If you look at this example, well, if you see the intrinsic problem with this example, you get a cookie from me. Anyone see it? Okay, the problem with the select syscall is that it doesn't scale, or at least it scales, but exponentially, not linearly. What happens is, if you have one file descriptor that you need to monitor for changes, hey, select will do it for you, and will do it reasonably well. 2 file descriptors, not a problem, but if you have 1,000 file descriptors, what you need to do, you need to repopulate the poll set before every syscall, and then scan it afterwards, which means that you're, well, by the time you have 1,000 or 10,000, 1,000 or 2,000 file descriptors, your application will probably grind to a halt and spend all its time in scanning and populating the poll sets. Now, oh, hey, that's exactly what I just told. So, there are more efficient APIs like epoll, which is which is the native API on Linux. There's KQ on the BSD and OS X, though it's pretty buggy on OS X, but OS X is buggy in a general sense. No, it's true. If you're a system programmer, well, you cannot but hate OS X. If you want to know stories from the trends, ask me afterwards. I'll be happy to share them. Okay, so back to epoll. Epoll is a lot more efficient because what you do, you add a file descriptor to the poll set once, and afterwards you don't need to do all that much. The kernel will tell you when something happens, which is a lot more efficient. In this example, okay, so we call epoll wait. That means you ask the kernel, hey, put me to sleep until something interesting happens, then wakes me up. And what you get back a list of file descriptors that are ready to be read or to be written to. It's a lot more efficient. Yeah, so this is the part where my battery was dead. The intention was to illustrate the Windows model, which is actually quite simple. Windows uses something of a thread model, only more efficient. What you do on Windows is you tell the kernel, hey, I have this handle. Windows doesn't have file descriptors, Windows has handles. And I expect that in sometime in the future, data will come in, or that it should be possible to write out data. You hand it off to Windows, and you can go and do something else. And when the time comes, Windows gives you a tap on the shoulder and says, hey, here is your handle, and these events are pending. Yeah, I had some really great illustrations, but I think this concludes the talk. But I'll be happy to answer any questions you have. No questions at all. Then, yeah, no live demo, no interesting pictures. So what should I do? A little dance? How are we for time? Yeah?
So if there are no questions about NODEJS or anything, then...
I don't believe for a second that I explained it that well. Oh, stories about OS6. Okay. I'll have to warn you, I'll be foaming at the mouth in 5 minutes. But the thing about OS6 is supposedly certified POSIX, which means POSIX is the body that governs Unix, the Unix specification, and checks implementations for compliance. So supposedly OS6 is POSIX compliant, but once you actually start to use it, you discover that, for example, pthreads, that's the Unix threading API, POSIX threading API. OS6 implements it, but maybe 80%. Only if you want to do really interesting stuff, you need the other 20% that either simply doesn't work or that locks up your kernel. Locks up your operating system. Yeah, it's just bad, man. It's just... I mean, I have no love for Solaris as well, but at least it's 10 times as good as OS6. Yeah.